Welcome to The Explainer. Today we're going to talk about a fundamental chemical reaction that's happening all around us, all the time, from our own kitchens to massive industrial labs. We're telling the story of neutralization.
All right, let's start with a little puzzle for you. Think about the sharp, sour taste of a lemon, the slippery feel of a bar of soap, and the little white crystals of table salt. I mean, they seem totally unrelated, don't they? Well, stick with me and you'll see how chemistry ties all of these together in a really cool way.
So to get to the bottom of that puzzle, we've got to meet the two main players on our stage, our chemical opponents, acids and bases.
Okay, so this really gets to the core of what these things are. When you boil it all down, an acid is something that gives away a tiny particle called a proton, and a base is something that takes it. It's really just a simple game of chemical give and take.
So when you hear proton donor, what does that actually mean? Well, when an acid gets dissolved in water, it basically lets go of these positively charged hydrogen ions. And here's the cool part. A hydrogen ion, it's pretty much just a single proton. That's it. And that's what gives acids their classic properties, like that sour kick you get from a lemon.
And then on the flip side, you've got bases. Their main job in life is to neutralize acids. Now, there's a special kind of base you'll hear about called an alkali. An alkali is simply a base that can dissolve in water. A simple way to think about it is all alkalis are bases, but not every single base is an alkali. And it's these alkalis that give things like soap that slippery feel and make them so good at cleaning.
Right, but here's the thing. Not all acids and bases are created equal, not even close. Some are incredibly strong, others are pretty mild. And to figure out how strong they are, chemists have this special tool. You can think of it as the arena for our chemical showdown, the pH scale. And here it is, the famous pH scale. It's basically a spectrum that runs from 0 all the way up to 14. See that number right in the middle, 7? That's perfectly neutral. Think pure water. Now, anything with a pH below 7 is an acid, and anything above 7 is what we call alkaline. So here's the main takeaway, the rule of thumb really. The further you get from that neutral middle point of 7, the stronger the substance is. So really strong acids, like what you'd find in a car battery, are way down there between 0 and 2. And the really strong alkalis, like a heavy-duty drain cleaner, they're all the way up at the other end, from 12 to 14. And get this, we can actually see the pH of something. It's pretty cool. We use something called a universal indicator, which is basically a special dye that changes color depending on the pH. It'll turn this bright, fiery red in a strong acid, green when it's neutral, and then a deep blue or even purple and a strong alkali. It's literally like a chemical rainbow.
Okay, so we've got our opponents, we've got the arena. What happens when we actually put an acid and a base together? This, right here, is where the action happens. It's a reaction called neutralization. And, the name says it all. The two substances, they basically just cancel each other out. All those unique properties, the sharpness of the acid, the slipperiness of the base, they just disappear. And in their place, you get two brand new, totally neutral substances.
Okay, let's zoom in and see what's happening at the molecular level, because this is the important part. Remember those hydrogen ions, the H+, that acids love to give away? Well, the alkali brings its own special particle to the party, a hydroxide ion, or OH-. And it turns out these two are a perfect chemical match.
This simple little equation you're looking at, this is the heart of the whole thing. The hydrogen ion from the acid plus the hydroxide ion from the base, they come together to form H2O, which of course is just water, a perfectly stable, perfectly neutral molecule.
But hold on a second. Water is only part of the story. When those H+ and OH- ions get together, they leave their old partners behind, right? So, what happens to the bits of the original acid and base that are left over?
They form a salt. A salt is what's known as an ionic compound, and it's made from the positive part of the base and the negative part of the acid, basically the leftovers. It's the second product you get from every single neutralization reaction.
And this brings us right back to our puzzle from the beginning. That regular old table salt you put on your food, sodium chloride, that's just one of thousands of different salts. It's exactly what you get when you neutralize hydrochloric acid with a base called sodium hydroxide. So there's our answer. Lemons, soap, and salt. They're all connected by the chemistry of acids, bases, and neutralization.
Now, chemists are really good at this. They've basically got it down to a science, with specific recipes for creating pretty much any salt they need. And it all just depends on the ingredients you start with.
So you can see here there are 4 main recipes for cooking up a soluble salt. You can take an acid and mix it with a reactive metal, an insoluble base, a carbonate, or an alkali. Which recipe you choose really depends on the exact salt you're trying to make, because as we're about to see, each one produces different results.
Just take a look at the difference here. If you react an acid with a metal, yeah, you get your salt, but you also get hydrogen gas, which is flammable. Not ideal. But if you react an acid with a base, you get your salt and good old stable harmless water. See? A much cleaner, tidier reaction.
And for those times when chemists need to be super precise, especially when they're using a soluble base, an alkali, they use a technique called titration. All this equipment lets them add the exact amount of acid they need to perfectly neutralize the alkali. No more, no less. That way, they know they're getting a really pure salt solution at the end.
So, at the end of the day, the story of acids and bases, it isn't really a story about opponents fighting each other. It's more of a story about 2 opposites, a donor and an acceptor, that come together to create a perfect balance. And in the process, they make something totally new and stable. It kind of makes you wonder, right? What other opposites in our world could create that kind of perfect balance? Thanks for joining me.